Hello everyone. In the course of this video, I'm going to be explaining this question in case you come across it in your jam. So all you just have to do is to click on the plus sign to follow me on TikTok, share, like, and comment because you never know what will happen when you share knowledge. When you share knowledge, you share power. Hallelujah. Now, also, if you go to my bio, you will see the link that will take you straight to my YouTube channel. There you can subscribe and click on the notification bell. Share, like, and comment also so that you will be one of the first to receive our videos. Why am I stammering now? Okay, action. Okay, 200 cm cube of oxygen diffused through a porous plug in 50 seconds. How long will 80 cm cube of methane take to diffuse through the same porous plug under the same conditions? Ignore this, ignore this. This one is not affecting the question anyway. Chemistry, they just want to confuse you. Now, Graham's law of diffusion states that the rate of diffusion of a gas is inversely proportional to the square root of its relative molecular mass. Its rate of diffusion and what molar mass. What is volume now doing here? This is why most of the times people love physics, or rather they prefer physics to chemistry. Now, what is volume doing here now? Well, to me, I prefer chemistry to physics because in chemistry, you solve, you have fun, and without chemistry, let me not speak further. So if you prefer physics to chemistry or chemistry to physics, you can drop it in the comment section. Let's argue science. Now let's go. Now it says 200 cm of oxygen. Now I told you time to time numbers. If you're watching my previous videos, when you see questions like this, the best thing to do is write out the parameters. So the 200 cm of oxygen. Follow me. Let's move closer. Okay, so we say volume. I'll represent V as volume. Volume of oxygen. You know oxygen is O2 in its free state. So volume of is that is the atomic in its free state, which is O2. So volume of oxygen is what? 200 cm cube. 200 cm cube. Okay, we've written that. Say the volume of oxygen diffused through a porous plug in 50 seconds. Time. The time is what? 50 seconds. 50 seconds. How long will 80 cm cube of methane? Okay, cm cube of methane. Let's leave this space for molar mass of oxygen. I'm coming now. The volume of methane is what? It says how long will 80 cm cube of methane? 80 cm cube of methane. Remember, methane is CH4. If you want to know how we got this, watch my previous video. I dealt with alkanes, naming of compounds and what have you. Okay, how long? Anytime you hear how long, as a chemist student, you know that it's time we're talking about. We don't know. So this is what we're looking for in the question. Will it take to diffuse through the same porous plug under the same conditions? Molar mass of CH4. Remember, under the same condition is Graham's law, and Graham's law is this with rate of diffusion and what? Molar mass. So there must be molar mass. So we have to solve for the molar mass of oxygen. Let's come here a little. Now, molar mass of oxygen, no oxygen is free state is O2. So therefore, O2, I'll be having what? Mass of oxygen is 16. So 16 times 2 will give me 32. That is 32 gram per mole. Come here, I will say this is 32 gram per mole. Now, the same thing here. Having CH4, it will be mass of carbon 1, 12, oh sorry, hydrogen is 1 times 4, which is 4. 12 plus 4, I have 16. So come here, I have what? 16 grams per mole. Please watch to the end. 16 grams per mole. And let's introduce the formula. What does the formula say? It says the rate of diffusion of a gas. That is the rate of oxygen over the rate of what? Methane. They are inversely proportional to their square root of their molar mass. So, which is the molar mass of, since it's inversely proportional, here will be methane. Here will be what? Square root of, here will be oxygen. You can see the rate of diffusion is inversely proportional to the square root of their molar mass. Now, I want to show you something now. Now, this is where it becomes what? Interesting. Rate of diffusion is equal to V over T. Hallelujah. Rate of diffusion is the volume over the specified time. So anywhere we see arrow, we can substitute in what? V over T. So having arrow here, I can say what? V over T of oxygen over V over T is the same thing as rate of methane over the rate of the molar mass of methane. what's the square root, sorry, square root, don't be annoyed, really sorry for that. And the square root of the, trying to look at this thing, of oxygen. Okay, now that we're here, let's substitute in our values. What is the volume of oxygen? 200, and the time 50. So I have 200 over 50. Okay, 200 over 50, yes, over the volume of methane. I have 80 over, now is the time we're looking for, so I'll just leave it as what? T is equals to the square root of, this is 16. Am I right? Yes, the molar mass of methane is 16 over the molar mass of oxygen 32. Okay, now let's do some simplifying. 16 here will give me 1. 16 here will give me 2. True or false? True. 0 cancel 0. 5 here will give me 1. 5 here will give me 4. So therefore I have 4 over 1 divided by 80 over t. As you can see, 4 over 1 divided by 80 over t is equals to, the square root of 1 is still 1. So no need to put down square root again, over the square root of 2. Okay, now let's simplify the what? 4 over 1 times what? T over 80. 4 here will give me 1. 4 here will give me 20. So therefore, this t equals to 1 over root 2. Okay, square root of 2. So I have what? Cross multiplying, I have root 2t, or t root 21 is equals to what? 20 times 1 will give me 20. So dividing both sides by root 2, I have t is equals to what? 20 divided by root 2. And root 2 is what? Root 2 is 1.414, and the list goes on. 1.414, I'll rest my case here. Divide, which is equals to, so 20 divided by 1.414, I have what? 14.1 seconds. So you can see. So you can see it is very easy. You can see the solving. I first brought out my parameters. Then I introduce this formula saying rate of diffusion equals to V over T. So anywhere I see R, I'm going to introduce V over T. Then normal simplification mass. Thanks for watching. God bless.